Assalamu alaikum. Welcome again to the online physics course with our grade 10 students with Miss Mona Sha'lan, Dakahlia STEM School. Let's complete the fluids revision of learning outcome 9. Hydrodynamics talks about Bernoulli's principle, and let's complete some problems that we solved on it. Number one, let's say that in your room you are really hot, but you know that it is nice and cold both outside your window and outside your door. If you open up your window to try to let the fresh air to come in, there will not be a much temperature change unless the door to your room is open to air out the hot air. This reason occurs because let's see the choices. If the door is closed, it will become a high pressure area built up from the hot air inside. Of course, there is a larger temperature that causes the hot molecules to increase the pressure, so there is a region of high pressure inside the room. And the right outside the door will be a little pressure, of course, as the cold air outside has a low pressure value. When the door is open, the hot air exits quickly, and the cold air does. Of course, when we open the door, there is a change in the pressure. There will be a pressure difference created that the pressure will transfer from the high region of the hot air to the lower one, that is of the cold air. When the hot air exits, there is a low pressure outside, meaning that the cold air will come in immediately on opening the door. Of course, the hot air will exit up and creates a low pressure in the outside. So the cold air will be moved in towards the room. When the hot air exits, there is a lot more pressure outside. Now will be a low pressure outside. So the correct sentence are A, B, and C. Second question. The following figure represents the streamline flow around an airplane wing during its motion as the plane is. This streamline causes a variation of velocities as there is an increase in velocity here which causes a decrease in pressure, and there is a lifting force from a high region into a lower pressure region, so the plane will be lifted up. Question number 3. In a storm, sometimes the lights of attached houses are blown off. This is because a high velocity wind is here will cause a region of decrease in pressure above this roof, and therefore there is a greater atmospheric pressure here inside the room or inside the house that lifts the roof up. Okay, so there would be a high velocity wind over the roof that decrease the pressure. When a fast moving train rushes past the train platform, the person who is standing very close to the edge of the train platform can be harmed as. Okay, fast moving train, so there is an increase in the speed in the front area than the behind area. So there is a pressure difference that the region of larger speed will have a smaller pressure. So the behind area pressures will become greater than that of the front area, and this would cause the man that is standing in close to this edge of the train to be pushed down, or to be pushed, to be fallen off and be harmed, okay, due to the variation of pressures and that is caused by changes in velocity. Okay, what is the condition for making an airplane rises upward? To be lifted upward due to variation of velocities, the velocity of the air in the upper side must be, okay, Sorry, there will be a mistake here. The velocity of the air of the outside upper side here must be more than that is the bottom to create a region of pressure difference. That this region will have a higher speed, so it is caused to create a region of low pressure, and here is the velocity decreased, so there will be a region of a high pressure, so it will be lifted up. To be lifted, the lift force must be larger than that of the weight force. So that's the correct one. An airplane has a mass of 18,000 kilograms, and the total wing surface area is about of 50 meters square during level flight. The pressure on the lower wing surface is about 5.25 times 10 to the power 4 Pascal. What is the value of the pressure on the upper wing surface? Here we have two values, two regions of pressure, pressure in the lower area and pressure in the upper one. As the pressure in the lower area is larger than that of the above one, so this pressure difference equal to force over area, which produced due to the pressure produced by the weight of the airplane over its cross-section area of the wing. So this lifting force or this weight force equals to mass times gravitational field strength. So by substituting for the value of the lower pressure region, which is this value here, and subtracting the value of force over area here, we get the value of the upper pressure. Okay, let's compare this value of the upper pressure with that of the lower pressure. We can conclude that the upper pressure is smaller than that of the lower pressure. Okay, the this figure shows the flow of a liquid in a tube with different two cross-section area as shown in this figure. The arrows shows the direction of the flow from the wide end to the narrow one. Which of these statements is correct? Read this first. The volume of the liquid entering from the wide opening. This volume is greater than this. Of course not. The volume flow rate is a constant. The flow rate entering the wide pipe is greater than that of the narrow wide. Of course, this is not correct as the flow rate is constant and then there is a conservation of mass. Velocity of fluid leaving the narrow pipe here is greater than this wide end. Of course, this is correct as there is an inverse relation between the cross-section area and the speed. The last one, the mass of the liquid passing through the narrow pipe per unit time is greater, and also this is not correct as the mass flow rate is a constant. In this figure, if the flow rate of water through the tube is 250 kg per second, what is the difference in pressure between the two sides, B1 minus B2? Let's show the diameters as shown here. Here is 10 centimeter and here is 40 centimeter. By putting the relation of here is the mass rate, so the mass flow rate is given. So the mass flow rate is a constant. From these relations, by knowing the density of the fluids, which is 1000, and the differences here in diameters, so we can get the value of the velocity for the two sides. Okay, two can complete it or can substitute in Bernoulli's principle by the value of velocities and get the value of pressures. So we used the continuity equation, substitute in the continuity equation to get the value of the velocity first and then substitute in Bernoulli's equation. And here most of the problems requires this steps. Okay, so from here the mass flow rate is a constant, so the velocity here of this cross section, first cross section, will be of this value by converting the values of centimeter into meter, don't miss that, and then get the value of the two velocities and putting the pressure difference of the higher pressure, which is the pressure of the input region, minus the pressure of the output, equal to half density and times the variations of velocity square. Okay, so we can get the value easy of the pressure difference. This problem we solved in previous video. If the figure above, water is pumping from the lower level to an upper one. The water is flowing as shown from this point into to this point. The properties of fluid at point 2 compared to this point. So it required the properties of the upper point, not the lower one. It is a smaller cross section area, so it will have a smaller pressures and high speed. Okay, high speed and less pressure. Some liquid is flowing through a tube with a certain velocity and pressure. What will happen for both fluid's velocity and pressure when the tube cross section are decreased? Okay, the cross section decreased as shown here. The cross section decreased, so the velocity increases while the pressure decreases. This figure shows an aspirator. What is the scientific idea of this work? This is the chamber of a larger cross-section area, and there is a region here to be pushed out with a larger speed, and there is a constriction here. The pressure, the liquid will be lifted up, and here the region, the constriction, there is a larger cross-section area, so the pressure here is a high in high regions. It pushed towards the region of the constriction, and in the constrictions the speed will be increased, and this is based on Bernoulli's theorem. A fluid goes through this tube. If the point 1 considered at a height equal to 0, and the pressure at a point 2 is just equal, 1 is equal to the pressure that is at point 2. Here the pressures are equalized. Okay, what is the following statement which is correct? Let's review Bernoulli's equation, which is V1 plus half rho V1 square plus rho GH is a constant value. Okay, the initial potential energy equal to 0. Bernoulli's equation here and cancelling this value as they are equalized, and the potential energy here equal to 0. So the kinetic energy per unit volume at 1 equal to the potential energy per unit volume at 2 plus the kinetic energy per unit volume at kinetic energy plus the potential energy per unit volume at 2. Okay, liquid flows through tube of 1 end that has a cross-section area of 4 cm and the other end is 8 cm square. Which of the following has equal value at the two ends? If we compare the pressures here, there is a different cross-section area, so there is a difference in pressure and the differences in velocity, and also the density of flow, where the concentration of the molecules will be changed, except the density of the fluid, which is a constant across the streamline. Okay, what is the scientific idea before the idea of the common aspirator. We said that before, due to the variation between the cross-section area and the air, the water and the air outside, there is a suction of the air due to the pressure of water of the inside. So it will be sucked due to the changing of pressures from the high pressure region inside due to the increase in the diameter here. The cross-section area here is larger than that of the air, so the air will be sucked as it is lies in a low region of pressure. The following figure represents the spinning of a ball in a football game. Discuss the figure carefully, then decide which one or the ones of the following statements are true. Okay, what will happen here? We call this situations in the command effects as due to spinning or spinning the change the direction of the spinning will be in this direction. So the speed here will be increased, and so there will be a region of a low pressure here creates in this region, and in the other sides when it is spent in these directions, the speed will transfer in these directions, and there is will be a region of pressure here and high pressure region here, so it will be lifted up due to these variations of pressures, and it returns back due to Newton's third law and so on. Okay, let's read what are the choices here. The periphery of the ball is moving in the same direction as the air flow to the left. Here, the periphery of the ball, the outside of these balls moving in the direction of as it spinning to the left. So the direction of motion will be in this direction, so the spinning will be here. The periphery movement increases the pressure to the left. Now the speed increased to the left, so the pressure would decrease here. So this sentence is not correct. The pressure increases on the other side of the ball to the right. Okay, the speed increased, so the pressure would decrease here, and the pressure here to the right would increase. Again, due to the spinning of the ball to this direction, according to this arrow, the ball is spinning in this direction. So the speed of flow will be increased here. So the pressure will be decreased in this region to the left and to the right, and it comes back here. There is a region of lower speed creates a higher pressure region, so it will be lifted up to this direction, and then Newton, according to Newton's third law, it returns back and so on. Okay, so A and C are the rights. There is a force balance at two sides of the ball. Of course not. The forces here are variable forces. Okay. In which of the following cases the sucking of a liquid by a straw will be easier? Of course, at a higher atmospheric pressure, as there is a region of high pressure that moves the liquid inside the straw. If the atmospheric pressure increases from a certain climate region, the sucking of a liquid by a straw will be the atmospheric pressure increased, and so it will be easier, as there is a maximum or changeable pressure difference between the inside the lungs, which creates a region of low pressure, and the outside the atmosphere, which is a high region, and so the fluid moves easily. Pressure had the same unit as, of course, if we take the pressures Pascal, the kinetic energy per unit volumes in Bernoulli's principle. All these terms in Bernoulli's principle have the unit of pressure. Okay, here in pascals, and all these terms, kinetic energy per unit volume also is a pressure, has a pressure units, and the potential energy per unit volumes also has a pressure unit. So the kinetic energy per unit volume half mv square over v. Tidal is, sorry, but we can't add quantities that aren't of the same unit together. Of course, they are, all of them have the same units of pressure, as by making derivations to these quantities to get the unit of pascals, we can say that all these terms have the pressure unit. Tidal generator is one of the power plants which of the following statement describes its basic idea. Bernoulli's principle, of course, is the tidal generator works on the changeable velocities or the change in pressure due to change in velocity. Which one of the following is a characteristic of a fully developed laminar flow? Fully developed laminar flow, of course, the velocity is a constant or the velocity profile doesn't change in the flow direction. The last question. Which one of the following is the characteristic, fundamental equation that relates pressure to the fluid? This be pressure and height, all as known as Bernoulli's equation. Thank you.